Since the dawn of humanity, we have sought to control or destroy Microsoft Excel. Now we stand on the precipice of a new age where we will be able to harness this power with Python. Hello, I'm Sweigart. I'm mainly known as the author of Automate the Boring Stuff with Python and several other programming books, which are available for free under a Creative Commons license at inventwithpython.com. Thank you for attending my talk on editing Excel and Google Sheets spreadsheets from Python. I'd like to thank all of the conference organizers for putting together Python WebConf 2023. Bringing a conference together is an extraordinary task, and I appreciate the opportunity to give this talk. You can find the slides of this talk yourself at bit.ly/editexcel2023 Python WebConf. So this talk is on how to interact with spreadsheets from Python code. Now, I don't want to bore you with a ton of technical details. This talk is more of an introduction just to show you what these two modules, OpenPyXL and EasySheets, are generally capable of. You can install them with these pip commands, and you can always dive into the documentation later. If you're watching a recording of this talk, we are here in March of 2023, and I'll be covering version 3.1.2 of OpenPyXL. Now, in the future, some of this code might change a little, or it might change a lot, but you can always follow along with this particular talk's code by telling pip to install version 3.1.2 specifically. It's a good version today. It'll still be a good version years from now because code doesn't rust, except, of course, code written in the Rust programming language. Now, the EasySheets module, on the other hand, you always want to install the latest version of that. It relies on Google Sheets, which is an online service. So if you aren't using the latest and greatest version, there's a chance that it might not work. I'm the author of EasySheets, and I take care not to make any backwards incompatible changes. So the code in this talk should still work for the foreseeable future. As a side note, if you're somewhat new to programming in general and you don't feel comfortable working with the command line to run pip, you can also run pip from the interactive shell using the pip from REPL module. Now, of course, you need to install the pip from REPL module first, but you can do that by copying and pasting this arcane looking instruction right here. This will run pip to install pip from REPL, and once you have that, you can import it and then just call its install function and pass it the module name that the package name that you want to install. This is really nice because this will work no matter what operating system you're on, no matter what version of Python you have, or what your virtual environment or path environment variable is set to. So if you're leading an introductory workshop or giving a talk to an audience where there's going to be a wide variety of computer setups, this just works. Okay, so with that out of the way, let's dive into editing Excel and Google spreadsheets with Python. Now, Excel is a towering monolith of an application. It has been with us forever, and it has guided human evolution. The first Windows version came out all the way back in the 1980s. And if you've used a computer for a job at any point in the last quarter century, you've likely used Excel. It really needs no further introduction. The Excel chapter of my book, Automate the Boring Stuff with Python, is actually one of the more popular chapters of the book. However, speaking of books, I'd be remiss if I didn't mention Python for Excel from O'Reilly by Felix Zumstein. And if you like the information that I give in this talk, but you want to know even more, I've read this book. I really recommend it. My book just has a chapter on OpenPyXL, but this is an entire book on not just OpenPyXL, but several other Excel-related modules for Python as well. It's well written. It's super useful. I recommend it. The second half of this talk covers EasySheets, which is a module for reading and writing Google Sheets spreadsheets. Now, this is a module that I created because the Google API can be somewhat tedious to work with, especially if you have only a simple use case. And the Google API documentation is it's fine once you get used to it. It can be a lot to wrap your head around at first, though. If you're a software engineer and you're creating a product that uses Google Cloud services, including Google Sheets, then it probably makes a lot of sense to go ahead and take the plunge and get a deep understanding of Google APIs. But if you just really need to read and write to a Google Sheets spreadsheet, EasySheets makes that pretty easy. I didn't think too hard about the name when I came up with that. EasySheets uses calendar versioning. That's where the version number of the software is the year.month.day of the release. Since this relies on an external system, which is Google Sheets Online, you really do want to be using the latest possible version, because sometimes the online service might make changes and then I have to release newer versions of this. And also just because a lot of open source packages that connect to online services, they have a habit of falling to the wayside because life gets busy and the volunteers can't continue to maintain it. But I always try to update the description of this module to include the last time that it was tested and confirmed to work, just to give you that added reassurance there. Now, for both Excel and Google Sheets, you can really think of a spreadsheet as kind of like a two-dimensional list data structure. So spreadsheet users typically use spreadsheets in two different ways. One way is, as you see it right here, where you have the columns are the attributes of whatever data you're trying to capture, and then the rows are the individual records of this data. Usually the first row is just used for the labels of the columns right here. Now, these are spreadsheets that sort of store data, and maybe a database would be better, but a spreadsheet is far more accessible, especially if you only have a few dozen or a few thousand records and not millions and billions of records. So that's the great thing about spreadsheets, is that they're really easy for non-technical users to use. Although, if you want to raise your blood pressure by like 10 or 15 points, Google spreadsheet horror stories, and you will learn about all sorts of million and billion-dollar mistakes made because of some tiny little detail in some spreadsheet somewhere that caused a minor disaster. And now the second way that we tend to use spreadsheets are sort of like as these forms that have a static layout, and we'll add like colors and positioning and everything like that. And then we'll just fill out numbers into these forms, and those numbers get used to populate these graphs that we automatically generate. These are really nice spreadsheets that you would use in a report for human consumption. So there's this flexibility in the ways of handling data that spreadsheets allow us to do without having a computer science degree. And that's really what has made Excel such a ubiquitous application. And then Google Sheets came along, and all of a sudden, you don't even need to install a spreadsheet application on your computer. You can just access it through your web browser, and you don't even, you can just share it over the internet with people. So spreadsheets are really great, but they're not completely perfect for every person in every situation. Nothing really is. So the things that make spreadsheet applications really great are that they're an accessible tool for working with human-sized amounts of data. Like, I'm pretty nerdy, but even I wouldn't want to just type raw JSON into a text editor for hours on end. I'd much rather use Excel. So your application's users might not know like structured query language for databases, but your application importing or exporting spreadsheets, that's something that your users could understand. Now, over time, users have been getting more and more sophisticated, and Excel has added several features to it, including its own scripting language called VBA. VBA stands for Visual Basic for Applications, and Its syntax is based on Visual Basic, which was Microsoft's programming language for making graphical Windows applications back in the 90s. And that was based on a language named BASIC, which was made at Dartmouth College in the 1960s. Computing history is fun. There's a huge history to follow up there if you want to. So there's VBA. So why use Python for spreadsheets? Well, this is a Python conference, and I don't have to convince you. You already know that Python is this widely popular language. It has a readable syntax, and it's a great language to work with, whether you have personal small projects or massively scaled up projects. Now, VBA is a fine language, but if you spend time to learn it, it's really only useful in Excel. Meanwhile, Python is everywhere. If you're making a web app and that exports data to a spreadsheet, Python can do that. If you're not even a developer, you're just in accounting or sales and you need to generate reports as Excel spreadsheets, Python can do that. So on the one hand, we have these accessible spreadsheet applications like Excel and Google Sheets. And on the other hand, we have very massive, expensive data warehouses, and they require a lot of specialized technical skill to operate. So as spreadsheet applications and spreadsheet users have become more and more sophisticated, Python is still a great language for handling both ends of that. It's a language that entry-level developers can use, but it's also powerful enough that world-class companies rely on Python for their critical infrastructure. So in fact, let's get more specific with some use cases. I'll have those on the next slide, but what Python modules like OpenPyXL and EZSheets do is that they turn spreadsheets into Python data structures. That's the thing that you should keep in mind in general when you're thinking about what can you use OpenPyXL and EZSheets for. So we have a bunch of data in spreadsheets, and we want our Python code to access that data and do something with it. That's what OpenPyXL and EZSheets enables. Now, you've probably thought of some of the ideas on this list already, but some of them you might not have considered, so I'm going to go over them. First, keep in mind, you don't need Excel running for Python to edit spreadsheets. You don't even need Excel installed at all. OpenPyXL is going to be working off of these spreadsheet files, those .xlsx files. So you could have a Raspberry Pi sitting on a shelf somewhere, and that's generating Excel spreadsheets for you. Or next, say you have a folder with thousands of spreadsheet files, like you had some service that was generating a spreadsheet every hour for the last several years. You would not want to be the human who has to go through every single one of those with a mouse and keyboard. And I would know this because I am human, and also humans make mistakes. So I would much rather write a Python script to go through those thousands of spreadsheet files to make updates or say check for invalid or missing data so I could clean that data up. Or maybe there was some update that relies on some complicated logic, something that's a bit more than just find and replace. You could use VBA to write that code. However, again, you would have to learn an entirely new programming language for that. So if you already know Python, you can then write Python code to do that. There's a whole term in data processing called ETL, and these are systems where you're extracting the data from a spreadsheet or a database or a CSV file or text file or something like that. And then you're going to do some transformation on that data, maybe some calculations based on it. And then you're just going to load it into some other spreadsheet or database. Now with OpenPyXL and EasySheets, you can use spreadsheets as a medium of data. It's like another data source that you can use. So another thing is, if you've ever used Google Forms just to create a survey or you have some data entry system, it's really great because you can post it online. It's accessible over the internet. You don't have to worry about maintaining this. All of the Google Form submissions are actually stored as Google Sheets spreadsheets. So you could write a Python script that just automatically checks every 10 seconds for new submissions made through that Google Forms survey or whatever you have, and then just process those in real time. So now you have Python scripts that can be sort of controlled or fired off by entries to a Google form somewhere. And finally, if you're just the software developer on a small team with other people who aren't programmers, they probably do work involving spreadsheets all the time. And they might have their own little setup and their own formats for their spreadsheets and things like that, so that commercial tools won't really help. It'd be super helpful if you could just write a small script or some in-house tool that can then help them automate their processes. Okay, let's dive in and look at some code. Again, I'm not going to bore you with this exhaustive list of functions and things like that. That's what the reference documentation is for. But I want to give you a general sense of what working with these modules looks like. So we'll start with OpenPyXL. This is a Python module for reading and editing .xlsx spreadsheet files from Excel. So one really funny thing about these files is they're actually zip files. You can literally take a .xlsx file and rename its file extension to .zip and just open it as a zip file, and you'll find a bunch of .xml files in it. So it's not really a binary file format. Excel files themselves are really just collections of XML files, and this has made it really easy for open source projects to continue to work with Excel. Just a bit of trivia there. Okay, OpenPyXL concepts. Here's some general concepts that you're going to have when you're working with OpenPyXL. So those spreadsheet files, those are represented as workbook objects in Python. And those workbooks are going to contain sheet objects. So if you've ever opened up Excel and you've noticed the little tabs at the bottom, they'll usually give you several different spreadsheets that you can tab through. It'll be called sheet 1, sheet 2, sheet 3, but you can rename them. So a sheet object, that's the thing that has rows and columns, and at the intersection of those rows and columns are going to be cell objects. And the cell that's the part that it's a little box. It contains like the number or the text or whatever for that little data value that you have. But there's a lot more to cell objects than that. You can, of course, merge them with adjacent cells. You can set their width and height. You can change their background. You can change the font of the text, in that Excel spreadsheets are much more than just, say, CSV files, which wouldn't have those features. And OpenPyXL has functions for dealing with all of those as well. Here's just code that I copied from the quick start section of OpenPyXL. And this gives you a nice overview of what it generally looks like. They use this from OpenPyXL import format for importing, so that they don't have to have OpenPyXL dot in front of everything. I tend to avoid this. I prefer to have my code be a bit more explicit, but you can see right here, they're creating a new workbook object and they're storing it in this variable WB. So this is their brand new workbook. It's going to automatically have one sheet, and that'll be the active sheet. The active sheet in an Excel spreadsheet is just whatever spreadsheet was in focus and visible when the user saved that workbook. In general, though, you can also find, let's see, on the next slide, I have it where you can find the names of all the sheets here. But so we grab that sheet object from the workbook object, and then just like with dictionary keys, we can use the spreadsheet coordinates for the rows and columns. Columns are going to have letters. They're going to be the exact same as what you find in Excel. And then the rows are numbers, and they start at 1 and not 0. But here it's really easy. We can just assign this a new value directly to the cell, or we can append a whole list of values just to append to the next available row. And again, these cell objects, just like in Excel, they'll have data types associated with them. And so there's a mapping between Python types and Excel types. Integers are integers and strings are text. But even stuff like a Python date time will translate to an Excel timestamp. And finally, once you're done making all of these edits right here, you can then call the workbook object's save method to save it given some file name that ends with .xlsx. So one thing to keep in mind is that you're creating this workbook right here, but you're not actually touching the hard drive until you finally call save right here. And one thing that I like to do, just this is just general advice. I really, before I start messing around with any spreadsheet files, I like to just make a quick backup copy of that file, just in case I accidentally create a bug or something. You know, this is theoretical. I've never actually done this before, but I'll just have a backup file. And you can do that with the shell util module in Python. It has a copy file function right here. Now, for these workbook objects, let's just look at those in more detail. Generally, what you're going to be looking at is either creating this brand new blank spreadsheet by calling the constructor function for a workbook, but there's also this load workbook function, and then you can pass it an existing spreadsheet that you've created in Excel or some other system, and then you can load all the data from that into your workbook object. And then finally, you can then save it. In general, I like to save it as a different file name than the one I've opened. But if you just want to update what the spreadsheet is, you can just use the same file name as the existing one. Now, for sheet objects, remember a workbook object contains multiple sheet objects. You can see those with the sheet names attribute of the workbook. When the Excel application will automatically just add sheet 1, sheet 2, sheet 3 whenever we create a new spreadsheet in Excel. And so we can just grab one of those. Again, it's just like a dictionary key. You can just use the name or the title rather of the sheet, and that sheet object will have a title, and you can also reassign this to a new string to change it. There's also the active sheet, which is just the last one that was open and viewable in Excel when you saved the file. There's a lot of CRUD operations, the create, read, update, delete, these sort of standard operations. You can do that with the sheets in a workbook. For example, there's the create sheet method. Sheets also are in a list because they have an order. So you could say, I want to create a new sheet. We'll call it my bills. I'm going to set the index to 0, just so that it's at the very front instead of at the end by default. All of this is in the documentation. There's ways of moving sheets around, renaming them, deleting them from a workbook, et cetera, et cetera. And then each sheet contains cell objects, and there's going to be one cell object per cell coordinate, like A1 right here. Now, if you look at this and you grab from the sheet object, you just pass in the cell coordinates here, that's going to give you the cell object itself. Probably what you want is actually this value attribute. This is the text that actually appears inside the spreadsheet when you're looking at it in Excel. And again, these will have data types as well. There could be the integer 42, and it's not the text 42, or if it's a timestamp in Excel, it'll show up as a datetime object in Python. Now, if you want to deal with multiple cells at once, you could also specify an entire range. This is very similar to the Excel syntax for specifying a range of cells. So here I'm grabbing everything in this rectangular region of A1 to D5, and this will return a list of lists of cell objects, and those inner lists are just going to be rows of cell objects. But you could also just specify like just a column, just to get all the cells in that one column, or all the cells in one row, or maybe you want to grab all of the columns within a range of columns or a range of rows. Generally, what you'll use these in are for loops. And so here we're iterating over all of the rows in this range of cells right here. And then since those are rows, we have another for loop that just iterates over all the cells in that row, and then we can make whatever modifications or reading the data from that right here. Now, Excel spreadsheets are much more than just like a CSV file, which would just contain the data and that's it. There's a lot of features in Excel. Probably the main one that most people are familiar with are formulas. And so this is where you can have the value of one cell be calculated based on the values of other cells in that spreadsheet. And it could be as simple as just adding 2 other cells, or it could be very, very complicated. Some formulas have of course gotten like absurdly complicated, and that's sort of a sign that you should probably start using an actual programming language like Python. The thing about OpenPyXL is that it does not, it can't evaluate for Excel formulas. So when you open up a spreadsheet in OpenPyXL and you look at the value of some cell, it's going to just give you the actual text of the Excel formula itself. Now, if you've opened this spreadsheet in Excel before, Excel can evaluate that. And then if you save it, Excel, the application, will save this calculated value as a cached value. And you can read that from OpenPyXL if you pass data only equals true to the load workbook method. And then when you look at this value, you're going to see this cached value. Now, OpenPyXL has not calculated this value based on this formula. Rather, it's just reading what Excel added in when it evaluated that formula. So if you start changing this value, or if you change like the values of the cells that the formula reads, OpenPyXL can't update any of this information. And in fact, if you try saving this spreadsheet again, when you opened it with data only equals true, it's seeing this cache value right here. It's actually going, if you save it, it's going to overwrite the original formula with just this literal value here, which might not be what you want. So generally, if you're opening this workbook with data only equals true, you don't want to then resave that spreadsheet from OpenPyXL. Charts, another great feature of Excel. Yes, it is true that OpenPyXL does support creating charts, and that's all I'm going to go into it. That is, it's a bit involved. You have to create these series objects, and you have to give those like a range of cells, and then you have to create an object of the specific type of chart you want, and setting up all of these other minor things and positioning the chart and everything like that. The reference documentation online has all that. But if you're thinking, hey, I would like to have this Python code generate a bunch of spreadsheets, and also those spreadsheets can have charts inside of them, and then I'll email those spreadsheets to other people as a report. Yes, OpenPyXL can do that. It's in the documentation. Now, there are so many other features to OpenPyXL, but this is just an introduction. I can't cover all of them here. You can read more about this in Automate the Boring Stuff with Python or Python for Excel. But of course, the online documentation at openpyxl.readthedocs.io, that's the place that will have definitive answers to your questions. So next is EasySheets. This is a module for editing Google Sheets spreadsheets. And I made this module because I was trying to figure out Google's API for Sheets, and it was a bit of a slog. So I wanted to create something that would be easier for others to work with, even if it didn't have all of the features of the Google Sheets API. So there is a one-time setup process that is a bit involved, and a lot of the remainder of this talk is going to be covering that, because it's really helpful to see somebody go through that. This is all because Google Sheets is an online service, so authentication is really important. You can't just enter your Google account password into your Python script. That's a really bad security practice, so they don't even make that possible. Instead, what you have to do is go to the Google Cloud Services website. You have to create a new app project, and then this app project has to have access to the Sheets API as well as the Drive API, because EasySheets uses Google Drive as well. And then you have to set up credentials and download the credentials file. It's a whole thing, and I'm going to walk through that right now. But just in case you're watching a recording of this and that process has changed in the future, you can always look at the EasySheets Git repo on GitHub, and the README will always have up-to-date installation and instructions. Now, again, this is just a one-time setup. You only have to do this once, and then your Python scripts are good to go. All you have to do is import EasySheets, and then you can start updating and editing Google Sheets spreadsheets. Oh yeah, and what you'll be using is any Google account. So this could be the one, say, that you have for your Gmail account. You can use that, but I recommend setting up a separate test Google account, especially when you're just beginning. You know, the free tier has more than enough of a quota for how many like API calls that you can make. That'll work out just fine for smaller projects. Uh, it's always been more than enough for me. But the steps that I'm going to go through right now, these aren't just for EasySheets, but there's also another module I created called EasyGmail for having Python interact with Gmail accounts. But this works for any time you want to use Google Cloud Services with any module or any programming language even. Now, people who are familiar with Google Cloud Services will probably say that I'm skipping over a lot of steps or I'm really oversimplifying things. That's kind of the point. I wanted to keep this as simple as possible. So now I'm going to Alt-Tab to the GitHub repo. Let's see, where did I have that? Ah, here we go. So this is the EasySheets repo on GitHub. I have the installation instructions right here. You can install EasySheets with pip. And then after that, you are going to want to go to console.cloud.google.com and then sign in with your Google account username and password. And again, it's probably a good idea just to use a separate test Google account for this. So then you'll be taken to this one web page where it has select a project at the top. Go ahead and click on that. You won't have any projects, so you'll click on new project and it'll take you to a window that looks like this. So it automatically, by default, gives you these names. You can go ahead and just use these names. I just set location as no organization. I just clicked on the create button. And then you can go back to select a project and then select the project that you've just created. So project in this case is sort of like an application that uses Google Cloud Services that you're setting up. Now we're going to want to say that, okay, we want our new project to be able to use Google Sheets API and also the Google Drive API because EasySheets uses that as well. So you're going to click on the hamburger icon in the top left of the Google Cloud web page and go down to APIs and services and then go to library. And this will show a page that has all of the many, many APIs that Google Cloud Services has. You'll want to find Google Sheets API and click on that and then click the little blue enable this API button. And then you'll want to repeat that for the Google Drive API. For those who don't know, Google Drive is sort of like Google's version of Dropbox or these other online file stores. Once you have that, you'll then, the next step is to then go back to the hamburger icon and APIs and services and click on the OAuth consent screen. This will be, you're going to be setting up what appears to the user, which in this case will be you, when you're trying to set the, give your Python script access to this project. There's going to be 4 steps to this, and I've already done it here, so I'm now editing this. But there's basically 4 steps, and again, you can just enter some common sense values right here. For the app name, I just have something generic right here, Python Google API script. Sure, whatever. And then the user support email. So I have my test account. I'm just going to use that Gmail account there. And I'm also going to do the same thing with the developer contact information. Then you can click on save and continue. You can then go to the second of these 4 steps. And this is setting up the scopes. And these scopes that's basically just a fancy word for permissions. You're going to want to say that, okay, this application or this project I'm setting up, I want it to be able to have the Google Drive API scope and the Google Sheets API scope. You can see here it's /auth/drive and /auth/spreadsheets. There are some narrower scopes, like there's a Google Drive API that's read only. And so that's kind of nice if you, just as a overabundance of caution, you want your Python script to only be able to have read access. to Google Drive or Google Sheets, you can have that. I just go ahead and use the ones that give all access. And you can see even down here, I've also added the Gmail API scope as well, because I'm also using EasyGmail for some of my scripts, and I figured I can just have all of that here in the same project right there. And when you click Save and Continue, the third step is about test users. You can just add your test Gmail account right here. This is there's a whole app verification process that Google has. You don't need to go through that. You can just sort of list your application as just like, oh, okay, this is just for testing right now. This is fine if what you're doing is just setting this up to access the Google Spreadsheets on your Google account right here. And then the fourth step is just a summary page. There's nothing to enter. It just shows you everything that you've done, and you can say, yep, that looks good. And then you can click OK on that. So once you have that, oh, there are even more steps. Okay, I'm doing well on time though. That's fine. You can go to the hamburger icon, APIs and services, and then you'll want to then create your credentials file. And so there's a credentials link in the sidebar. You can click on Create Credentials. There's 3 different types: API keys, OAuth client, and service accounts. We're going to be creating OAuth client. Again, it's very simple. You can use all the default values for everything. And once you've done that, you'll then on this page see that the credentials will be listed on this middle table, and there will be a download JSON button, and this will let you download your credentials JSON file. Now, it's going to have a really long, weird looking name, something like this. Go ahead and take that and rename that file into credentials-sheets.json instead, and then put that in the same folder as your Python scripts. Once you have that, then you can open up the Python interactive shell and just type import EasySheets. And EasySheets is going to automatically try to find that credentials file, and then it'll notice, hey, you also need these token files as well. It's a whole process, but this is the last step. Oh, minor note, treat those credential files as a password. Don't distribute it to strangers. You might want to add it to your git ignore file so you don't accidentally add it to a Git repo and then publish that online for everyone to see. I made a bunch of screenshots right here. So when you run import EasySheets, what's going to happen is it finds that credentials file and says, okay, I have to generate tokens. And that's generated by asking the user, hey, this application wants to use your Google account. Is that okay? So it's going to automatically open up your web browser, and then you can click which Google account you have. You might have to enter your username and password if you're not already logged in. It's then going to show you a scary looking screen that says, oh, Google hasn't verified this app. It's like, yeah, this is because you haven't gone through the whole application process. That's a whole other step. You don't need to do that to use EasySheets. So click on Continue, and then it shows you this is the OAuth credentials screen that you set up in the earlier step. And it's just going to say, hey, this app, and then this is the generic name that I gave it. This application wants to access your Google account. And then you can click Continue saying, yes, that's okay. And then actually, this is going to go all over again, because the first time it's asking, hey, can this application use your Google Sheets spreadsheets? And then the second time it's going to say, hey, can this application wants to use Google Drive? Because we're using both of those APIs. So you'll just click OK, 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 and then get to the end. And then it'll end up right here where it says the authentication flow has completed. You may close this window. And this is now you've done all of these steps. Again, you only have to do this once. And then after at that point, you can just import EasySheets and start using that code. Cool. So I have like 5 minutes left to cover all of the code aspects of EasySheets. So these are the 2 token files that that it's created. Treat these like passwords. Don't share them with anyone. There's also ways of revoking credentials if you do accidentally share them from the Google Cloud Services website. You can go to that credentials screen. There's instructions there. Okay, fortunately, EasySheets is fairly similar to OpenPyXL. There's a spreadsheet object, and that spreadsheet object is like a workbook. It contains multiple sheet objects, and then these sheet objects have row and column coordinates that you can sort of just treat as dictionary keys for reading the values off of a spreadsheet and then writing them. Again, you probably want to back up your spreadsheet before you work on it. It's a little bit more important in this case because there is no save method for EasySheets. All of these edits that you make by calling these functions, those are all done in real time, and then they are like permanently etched onto the spreadsheet on Google Sheets. So you might want to consider making a backup of that. I don't think there's a function for doing that in EasySheets right now. It's on the roadmap, but you can just open that spreadsheet in a web browser and then click on the make a copy menu item. So yeah, EasySheets is fairly similar to OpenPyXL. There's a create spreadsheet if you want to create a brand new spreadsheet, and it's going to have one sheet object associated with it. You can view that under the sheet titles attribute. Also, all these spreadsheet objects, they're going to have a spreadsheet ID, which is this complicated thing that's generated for you, and that is used in the URL, which you can also view under the URL attribute right here. So you could copy and paste this URL into your web browser, and then log into your Google account, and then you could just start modifying the spreadsheet there. Or what I like to do is just have a browser window open, looking at that spreadsheet, and then as I'm playing around in Python, modifying this, I can then see it update in my browser in real time. That's really nice when you're just doing development and testing things around. There's also ways of just loading existing Google Sheets spreadsheets. You're going to need, you can copy and paste the URL from your web browser and then just put it here when you're creating a new spreadsheet object. And then there's the same, create, delete, move around sheet object functions for or methods rather, for the spreadsheet objects. Those are all documented online. Really, here's what you want to do for reading and editing cells. There is a get rows method, and that will return the entire spreadsheet and all its data. So if you have a really big spreadsheet, this might not be what you want to do, but keep in mind that these are all API calls, and so you might not want to edit individually every single cell one at a time. Oftentimes it might be a lot faster and have less latency if you just get all the rows, which returns a list of lists, and those inner lists are rows of data, and then you can just make any changes you want, and then you can pass that back to update rows, and this will make a single API call and update the entire spreadsheet. But if you have a very large spreadsheet, you might want to just get a single row at a time with get row singular, and then you specify the row number right here. Remember, just like in Excel, the first row is row number 1 and not row number 0. Now you might notice that there's a lot of blank values at the end of this row, and that's because by default, Google Sheets set themselves up with 26 columns and 10,000 rows. So you can change this by reassigning these different numbers if you just want to shrink the general amount of like how big the spreadsheet is considered. Even if there's like blank values everywhere, you can do that. And then also, this is something I use all the time. If I just want to download my Google Sheets spreadsheet as an Excel file, this is what uses the Google Drive API. There's a download as Excel function, or method. There's also downloading as these other file formats as well. Now, the thing to keep in mind is that this is an online service that you're interacting with. So especially if you're on the free account, there's going to be quotas for how many API calls you can make. In general, it's going to be 100 read operations and 100 write operations per 100 seconds. EasySheets automatically handles this for you, but sometimes you can make a call and then it's blocking for several seconds or even longer as it's doing that. Anyway, that is my time. Thank you very much for having me. Again, There's so much more to do with these. You can check that out online. These slides are on Bitly. All of my books and other materials are on inventwithpython.com. Thank you so much to the organizers of this conference, and thank you so much to you for viewing this talk. And I'll see you later.